This is an unfortunate piece of UI design. The delete button for one of the comments overlaps the sandwich menu, or the dot 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 menu, whatever you would call that. It's not a sandwich menu, actually. It's a different kind of menu, but because I know what a sandwich menu is, and that's the series of horizontal lines. It's the dot 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 menu. Well, yeah, that's an issue. Oh well. How bad of a problem is that? I guess it's not that bad of a problem, because if you scroll to the top, it's definitely got some padding. Okay. I was just about to like point and laugh at Kik's UI development team, I guess, which would have been very mean. Okay, now let's pop out the YouTube chat as well. Okay. There we go. YouTube chat has popped out. Okay. Discord is discording. And we're good to go. Okay. This is the wrong window. Here we go. This is the one. This is the one we're looking at. Great. Fantastic. So, here we are within like 6 levels of nested loops and if statements. What are we going to do today? This evening? Well, what we did last time was we successfully sent 6 32-bit integers from the client to the server. That's pretty cool. What I've been thinking about is sort of what I want. I'm doing like a toy version of the functionality that I have, so I can just like test it out before I start trying to stick it into my engine, my game engine. So the test version, I think, is going to go as far as we've got 2 modes, I think. Okay, we've got, in my game, I want people to be able to spectate, and I want the non-spectator user experience. I don't know precisely what those 2 experiences are going to look like just yet, if I'm honest. Let's see. I'm thinking that the spectating user experience is going to be like the spectator sends a request to my server, and it says, I'm interested in client number whatever, and whatever ID they send over will correspond to the index in the array that I'm going to be looking into. So that's cool. That's convenient. Gonna want to bounds check that so that some random person can't like break my server. That'd be silly. Yeah, so the spectator says, "Hey, I want to know about this client, and I want to It's like there's a so on the server I've got to keep track of all the ints that they've sent me. Which is here. So I think what I want to do is have the spectator tell me either when they would like to start receiving data, like, hey, last I heard I got this back, send me everything that came after it. That would be the most sensible way to do it, actually. I last received index number whatever. I want everything that comes after that. Within reason. Okay, that's wild. Okay, so I've got to store. I have to store a lot of information here. I need to know for each of my clients whether they're a spectator or not. That much is certain. And how do I know if they're a spectator? Well, I need to add another layer to my handshake. So not only do they have to upgrade, but they have to then tell me what kind of client they are, which is going to make this this like even one layer more complicated. Now, how do I... Huh. I could replace this. Like, I could use this as a tri-state. I don't want to do that. What I would do is I would probably switch this for an int. And the int, instead of being is upgraded, is going to be like handshake state. Yeah. Does F2 work? No, of course it doesn't. Find, replace. Oh dear. That's a little bit concerning. I don't know what this is about. Using it in add client? I'm gonna have to figure that out. Okay, but it's an integer array. And I guess whenever we I'm sending like the pointer to it. Like the where is it? I'm sending the whole array. Yeah. Okay, that makes a little bit more sense. So we're going to have 0 for not upgraded, 1 for is upgraded but not specified whether it's a spectator or not, and then spectator. And at some point, I'm going to have this weird thing where there's like a lobby, I guess. Um, there's a lot of weird features that I need to add that I don't know how they're going to work yet exactly. Um, but like for one thing, the spectator's going to want like, hey, here's a list of all the users that are currently playing. Choose one of those, and I need that's a different kind of request than a regular spectator. Yeah, so I think, huh? What do I want to do here? I believe, actually, I just want to use one single array. I don't want to. Because what I could do is actually, this is not, maybe we don't call it handshake state. We call it like, I don't know. It controls what we do with the data that we receive. Is basically how it works. Like we're gonna be receiving bytes from our clients regardless, and we rely on this to determine how we react to it. So it's not handshake state because it's not like it goes 1, 2, 3. I mean, the values may literally be 1, 2, and 3, but it's not like it's not a straightforward like linear progression. It's actually going to be now like serving more complicated purposes. That's fine. That makes sense. What do we call that? Sure. Yeah. So we're gonna have like a bunch of switch statements that are controlled by that. Cool. And I gotta go figure out what I do with it. I can't control clicky, right? Gosh, that's pretty lame. Add client. You're not that anymore. Oh, I gotta change the. Yep. I'm just gonna call you like. Yeah, there's client state and client data. What could be more clear? But anyways, so add client. What does it do with client state right now? Okay, so we want to set it to 0. That's the first value it will have. Maybe I should set it to 1 instead. 0 could be like an error state or something. So I don't want to. I'm gonna set it to 1. 0 would be like what it is if it's uninitialized. I think when you have like a static array that you have uninitialized, it could be a 0. So let's just save 0 for an error state for whatever reason. Okie dokie. And then what happens here? So this should not be as simple as that anymore. Now it's going to be like if client state is equal to 1. What about where's the upgrade happen? Where or when does the upgrade happen? Oh, okay. So actually, here's the thing. I'm gonna have these be in sequential order. So now we're gonna do totally different arrangement. Oh my goodness, how will the code survive? What's gonna happen? If client state is equal to 1, then do this. Else, if client state is equal to 2, do something else. Etc. And so on. Okay, this is some crazy stuff. Huh. Well, let me finish looking at upgrade response. Okay. You're an int star. And what do I do with you? I set you equal to 2 now. Better handle remove client properly. Oh, interesting. Huh. In this particular setup, so for the real game server, I don't want to remove clients. Or at least if I do remove a client, I don't want to do this step. Right? I can't do that. That's not okay. Because I need the client to know that they can rely on the IDs of the other clients staying consistent. And the best way I know to do that is just to, keep an index for everything and have that be the ID. Yeah, because I guess I'm I'm making an assumption that's maybe not totally necessary, that maybe clients can leave in the middle of a game once a game is started, but they can't join. It's probably unnecessarily inflexible. I could do some kind of like lookup table or something. Yeah, I don't really want to worry about that. It's it's certainly possible to have like a dynamic table or something. Um, but I think we always end up with like sort of wasted memory, unless we do a linear search or we use a tree of some kind. Oh dear. Or a heap. Yeah, I'm not gonna think about that too much. I'm just gonna comment that what how would certainly I closed the client. I don't want to do this though. This is gonna make it break. Um, I don't know. Sure. Yeah, sure, whatever. All right. At least client state should be happy now, I think. Okay. Client state is 2. So I'm going to call state 2 um, well, this is just obvious. Yeah, we're not gonna, we don't do, well, okay, hold on a second. This is somewhat useful. You know what's weird? Yeah, you know what's weird is that this is all designed around handling text, and I'm not going to be sending text all the time. In fact, now that I'm not doing the chat server part, I'm almost never going to be sending text. So this is going to be a bit weird. This is going to be kind of outmoded. Okay, so forget this for now. We're really not doing that right now. What we need to do right now is get the first int out of the message. So what do we do in this case? We have to do some kind of error handling here. Basically, if we encounter an error, just don't do anything. But we need to be able to do like encountered error equals true break. And then here, what are we breaking? We don't break here, we continue here. Just don't process whatever comes next. Because we could have received multiple messages from a particular client. Oh, wait a minute. Oh, gosh. I guess I should handle the possibility that like the client sent me 2 messages like too quickly. You know? Oh man, how do I handle that? Cuz each message can result in a state change. Right? It's practically like it's practically like the user's navigating a menu, you know? This is curious. How do I want to handle this? Huh. Do I actually have to store any client state? Or, so what's the benefit of storing client state? I guess it means that, so if the client didn't, if I wasn't storing what kind of client the client was, then every request, every time the client sends me a message, they have to tell me basically what API they want to hit, practically. And that's not a lot of data in reality, is it? When you think about it, like if I have an int, a whole int, that's just 32 bits. So I'm adding an extra 32 bits to every message we send back and forth. Do I care about that at all? I don't think I should care about that actually. Because the alternative is I do this weird thing where I'm like, whoa, wait a second. The client is in non-spectator mode, and then they sent me 2 messages back to back. Where like, no, I don't like that. Okay, but wait though. Okay, but wait, hold on. These are separate messages that I'm looking at, right? These are separate messages. This is a bit weird. Yeah. Because, like, what if the client sends me 2 requests for more data, right? What do I do with that? Lost packages? Don't tell me about that. Hey, Master King, how are you? Don't forget messages degrade over distance, so someone with low ping might see benefits in the higher ping areas. In the higher ping areas, you'll run into problems. So here's the thing. This is not supposed to be like a really complicated server. All of those exciting problems I expect to be dealing with later on. That doesn't mean they're not valid. Of course they're valid. What protocol am I planning on using? So this is a WebSocket server. I think that answers the question of what protocol it is, but I'm not really experienced enough to be 100% sure. So it's a stream socket, and it's using I guess WebSocket is a protocol, right? Where you have to like do the upgrade handshake thing, and then you kind of just send messages back and forth whenever. That's my understanding of how WebSockets work. Um, so this is a tick-based server, and clients can send messages whenever. But I'm in control of the client. To be clear, like it's a game client. I'm writing the game client and the game server. So it doesn't actually have to be that complicated, I don't think. But I'm sort of like thinking this over right now, and it's like a little bit crazy. Um, so, okay, here's what we do. Here's what we do. It probably shouldn't happen that there's more than one message stacked up. But worst case scenario, I send the same message to the client twice. Right? Because the client, if there's actually important decisions like that the user needs to make, like first they click this button, and then only after they get the response back from the server they're going to click the next button. If that's actually how it works, then there's no way I'm going to get two messages from the client that's like, oh, click this button and get me the answer to the next thing. It's like, no, that's not really going to happen. Okay. So so this is a while true still, I think. This is still a while true. Yeah, I think it's still a while true. And here's what we're gonna do. We're gonna do this annoying thing. No stacking messages is good, just worry about more compression if that's the case. Yeah. And ultimately the amount of data we're sending back and forth I don't think is gonna be that much anyway. So I think it'll be okay. So what I'm gonna do is I'm gonna say the first 32 bits, 4 bytes. The first 4 bytes, I don't need 4 bytes to do this, but I'm going to use 4 bytes anyways. The first 4 bytes basically tells me what endpoint the user is trying to hit. Okay? And then if we just do a switch statement on the first 4 bytes. I think that's basically what we do. All right? So this is going to be like universal shared code no matter who you are, and we're going to say if the payload length is less than 4, you're doing something wrong. You don't know how to send me data. So we're just going to continue, which I think is safe. I'm not totally sure it is, but ooh, look at this though. Message pointer. I think I don't actually need message. I don't think it matters too much. Does it matter too much? Because okay, here's a completely insane thing. Technically, in WebSocket protocol, the user can send a single message split up as 2 separate messages. I'm not equipped to handle that. I'll be honest with you right now. I'm gonna pretend that possibility doesn't exist, because I've never, my browser has never done that before. I don't know in what situations the browser might decide to do that, but it's never done that before. So I'm just gonna assume that despite the fact that it's in the RFC, that never happens, unless it's a message that's like so long it needs to be split up. But I'm just not gonna send messages like that. All right. Okay? Alright. Good. Perfect. I'm glad you agree that that's a good idea. Okay. So, great. Next, um, we're gonna read. We're gonna read those 4 bytes as an int. How do I do that? How do I do that? Do I do like uh, uh do we do like int x equals where's the payload? I'm not very good at C programming. Decoded message in, I think, is the payload. Do I do this? Technically, decoded message in is a... what is it? A char star? So I don't know if it's gonna like automatically get the first 4 bytes or not. Right? You're coming from a rudimentary Python understanding. Deal with your schema. Set it to int64 longer than that. Then it splits. I don't know what you mean. No idea what you just said, my guy. I know what an int64 is. At least I think I do. Yeah, isn't a 64-bit int a long, basically? Huh. Or is it a long? Yeah, I think it's well, it depends. It's fine. It's fine. Look, this is totally gonna work, okay? This probably will get the first 4 bytes off of it, right? Especially if I cast it, right? If I sprinkle some magic fairy dust on it, it'll totally work. And then if I print it out, then we'll know we did it right. And I'll just comment out all this other stuff for now. Like with a float, it'll split 64 and 64. The message. The message will be split. I don't get how the message could be split. I understand you're trying to help me and this must be very frustrating. It's gonna be alright. Well, we'll still make it through. I'll just try stuff. Does this run? No. Oh, because I've still got that hanging out there. Okay, give me a sec. Okay, no, it doesn't like this. It doesn't like this at all. Cast, well, it's a warning, actually. Oh, I wouldn't cast it to an int star. That would be a bad idea. I'd be casting it to an int. Implicit declaration of printf. Where did I put printf? Okay. So the server's running. What I want my client to do... Alright, let me pull out my client here. How do I switch windows? Okay, here we go. Here's my client. It can send this. Sure, that's fine. Yeah, I can just send that again. So it should get 6, I guess. Do it. All right, let me open up my. Here's the running client. Inspect. Refresh. I think it just sent something. Now we pop back over to our server. And we ask our server, did you receive something? Hello. Did you receive something? It doesn't look like it received anything. What is this? I have one client. I thought it would have received something. Let me restart the client. Let me rerun the client again. Did you receive anything this time? Oh! Kill it! Kill it! What have I done? Oh my gosh. What's the point of type hinting without a schema? Okay. That's the part I don't understand. What do you mean by without a schema? So schema is kind of an overloaded term. I do some like database stuff at work. This is not work, by the way. So when I hear schema, I'm like databases, SQL. We're not doing SQL right now. We're doing, well, I don't know what we're doing, but so what do you mean by schema? Oh my god. What did I just do? Okay. So I think I messed something up here. I think I messed something up here with like the while true and the multiple message handling. Almost certainly, right? XML. XML. Bro. I don't know if you understand, but I'm dealing with C and binary here right now, man. There's no XML. The client's sending me raw binary. Now, maybe it's my own fault for not using XML. Okay. If processed bytes is less than received bytes... okay, so received bytes is what? Okay. When I receive from my client, it tells me what? It tells me processed bytes frame bytes. Okay, so this is the total number of bytes waiting in the wings, which could include multiple messages. All right. And or frames. Is frames the right term? Frame is probably the right term. It could contain multiple frames. And what am I doing here? I wrote this code. It's just been like 2 months since I looked at it. Processed bytes equals 0. I parse a frame. We're in the while loop. I parse a frame. And it puts it in the decoded message in. Process bytes plus equal frame bytes. If processed bytes is less than received bytes, message pointer plus equal frame bytes. And process bytes is getting incremented. So I should hit this break statement eventually. Huh. But I have this continue here. If header.payload length is less than 4, continue. But process bytes increments. But this is not. I kind of want to do like this, you know? And put everything else in else. Well, put nothing in the else, basically. Yeah, it'll work for sure now. It won't explode again. That's why you said like a binary float. Okay, if I use a big enough float, it'll split 64-64. Okay, I'm still not totally sure what you mean. I'm still not totally sure, but that's okay. Here's the client. What does that do to my server? I have one client. It's gonna pretend like it has no data to receive. It's lying to me. Now wait, so is restarting this what causes that? Huh. What? Say again? I received one of these things. Great, I'm so glad. Why doesn't it print this ever? Refresh. I'm definitely getting some amount of data from the client. It's just, it's not hitting this particular if statement. Bytes from client. Alright, I think I screwed up. I must have screwed up something. What I should have done actually is just like reran this again. Yeah, I should have just reran that. Because this was working yesterday. So I should just rerun this. Okay. Connect the client again. Yeah, it's not... Okay, I broke the handshake, I think. If I refresh the client... Yeah, I think this 8 bytes that I'm receiving is the handshake, not the actual message I'm trying to send. Alright, well, frick. Okay, here's what we do. Here's what we do. We get in a time machine. Hold on. I've got a time machine in my back pocket. Give me 1 minute. We get a time machine and we go back to the version of the server that was actually doing what I wanted it to do. Yes. Yes. And once we've completed our time travel, surely we will be able to send and receive ints again. Oh crap. The time machine didn't work. Panic. Everybody panic, the time machine didn't work. Oh, wait a second. No. I remember now. The problem wasn't time, it was my memory. Because... Oh my god. Because... Let me open up... Where's... Why can't I select the other VS Code tab? Why can't I select the other VS Code tab? What is happening? OBS. OBS. What are you doing? It's not letting me select the other thing. Now I can select it. Okay, Jesus, OBS. It only calls send after I've hit the send button. So I need to do something here to actually go do stuff for my server. I'm an idiot. Is basically what I'm trying to say. So we come back here to my server and received X. Huh? Maybe I have to send an empty string? Let me try sending an empty string. What? It's supposed to be like a sequence of ints. We should get this message. This is what the message I expect to receive is. What was the magic secret sauce that I said that would send? It should always send the... Oh. Okay, no, I understand now. This is crap. Okay, this is a me juggling too many files issue, actually. I opened the wrong client. This should be in game client. Yeah, okay. So I'm an idiot like on 2 levels. Oh my god. And then here, I mean, this should be... Oh. Okay, hold on. This file should be over... This file should be like that file, and that file should be like this file. Oh my god. There. Never open the chat client again. That's old project. Refresh. Send. The server's probably closed. Huh. Interesting. Let's try it again. Refresh. Send. It's still in connecting state. Did it connect now? Yes. Okay. Fantastic. After an hour of stream, we are precisely back where we were yesterday. Very good. Now, here's what we do. Now here's what we do. Okay. Now here's what we do. We're going to try the int thing again. Okay. I go to my client. I refresh my client. And I send the message. Check this out. I forgot the new line character, but this is okay. It does roughly what I expected it to do, I think. Yes. It's getting the first 4 bytes when I do this int x equals this. It's getting the first 4 bytes. Yes. I knew it. I knew that's how it worked. Yes. And then what we do is we effectively do a switch statement off of this to decide which of several functions the user wanted to do. Okay. So, if x equals 1, do one thing. If x equals 2, do another thing. What are the 2 different things we want to do? So I know one of the things that we do. Okay. So here, check this out. Okay. So if the user is a regular client and not a spectator, what the server needs to do is they need to store whatever information the client just sent over. We get the... I think we basically just do this. Yeah, what this is doing is it's figuring out how many ints must be in the frame, and then it copies them over to client data, basically. This is slightly weird because I should only be having a client data storage set aside for non-spectators, right? So like at the start, I do this thing where I'm allocating 4,000 bytes, 4 kilobytes or whatever for each client. I wouldn't do that for spectators. Spectators don't need all this allocated space. But that's fine. We'll worry about that later. Yeah, but if it's a spectator, okay, I should actually test this first. Test this to make sure this works. Because with C programming, evidently, I can't make large changes while keeping everything working. So we need to make very, very tiny changes. Okay, we flip over here to the client. I'm going to tell the client to send 1 followed by, I don't know, 3, 4, 5, 6. Yeah. Okay, so that's the change the client's going to have. And then go back over to the server, start up the client. I have 2 clients. Why do I have 2 clients? I have no idea. Don't know what the first client is. I sent the payload. So this is basically right, except it shouldn't be copying over the 1. It should be copying over everything that comes after the 1. So I just need to make like a small change here. The mem copy should be, this is the destination, I believe. This is the source. I need to do decoded message in +4. Right? Because memcopy is destination source. And source is a pointer. And if I add 4 to a pointer, it's incrementing by 4. And we know it's safe to increment by 4 because we know the header payload length is greater than or equal to 4. I mean, technically I should do, I don't know, this. If that's not equal to 0, or that's less than 4, error malform payload or whatever. Okay. Stop the server, start the server over again. Restart the client. Now we shouldn't see the 1. I have 1 client. Client sends a message. I receive 3, 4, 5, 6, 0. Okay, so there's an extra 0. I need to correct this by saying the number of ints is the payload length minus 4 divided by 4. Because the first 4 bytes of the payload are the frickin' signal to tell you what thing it's doing. Reconnect the client. I have 1 client. Send a message. 3, 4, 5, 6. Perfect. Perfection. That's exactly what you want. Okay. Now, I will make room for a spectator. A spectator is, I guess, let's see. How do we want the spectator to structure their request? Their request should, I guess, be client ID followed by last data index. Something like that. Which can both be ints for the sake of simplicity. But realistically, that's wasting data, whatever. Um, so what I would do is I would say first bounds check the client ID. Well, first get the client ID, I guess. Int client ID is equal to decoded message in 1 casted to an int. That's not how you do parentheses. And then last index. Yep. Actually, the first thing I should do is like check the payload length. Has to be divisible by 4. Has to be, how about I just say like header.payload length? Because it's going to be the same every time. If header.payload length is not equal to 12, then it's malformed. Because the first is this I don't have a word for it yet, x, and then these other two ints. And that's 4, each int is 4 bytes, 4 times 3 is 12, yes. So we get those two things. And we bounds check the client ID. If client ID is greater than 0, and client ID, hold on, I'd like to do my ands a little bit differently. Is there a num client? Yeah. So we know the client is valid. We should, I hate by this like nesting of if statements. I need to do something about this. It's a disaster. But we'll get to that. Last index. Can last index be invalid? Of course it can. If last index 0 needs to be less than that, and last index needs to be less than what? Needs to be less than what? It needs to be client data num elements I. This. It could be less than or equal to that, I think. Let's see. Client data num elements, client ID. Yeah. So they're asking. They're saying, I have received up until I should actually this should be less than. I've received for this client up until index number, I don't know, 5 or whatever. And I want everything that comes after that. That's basically what they're saying. Put a new line character at the end of everything. I wonder if Master King is still around. Or if I scared him away. Last index. So assuming all the bounds are checked, we actually send a message back. Which is what this is supposed to do. This is while true. This is supposed to, this is like the chat client stuff, right? This is like if you receive a message from one client, send it to all the other clients. Yeah. Well, we need to send it specifically to the client that requests this. We're doing something like this. Message out. Construct text frame message out. So message out. What is that? So I construct a message out from a message in. Huh. Okay. So I think what this would do is basically send the same message back to the client, which is not exactly what we want to do. Construct text frame. So this is what we're sending, and we need to modify this. Now we need to go look at our construct text frame. Okay. So this looks fairly generic at first glance. Here's the payload. We're using string length to determine the size of the payload, which is not what you want to do. Oh no, and I'm doing this putting the star in the wrong place. Oh no, we can't have that. So let's send in payload len. Yeah? Yeah, that's what we do. Okay, and we're going to construct a frame. Fin1, opcode 1. Text frame. I'm not actually sending text anymore, though. Okay, now it's time to look at the WebSocket RFC. 6455. What's opcode? Fin is gonna be 1, yeah. RSV. Okay. Opcode defines the interpretation of the payload data. If an unknown opcode is received, the receiving endpoint must fail. The following values are defined. 0x0 defines a continuation frame, 0x1 defines a text frame, 0x2 defines a binary frame. Okay. So it's not a text frame, it's a binary frame. So I need to add 1, I think, technically, to this. Now it's a binary frame. Easy as that. Okay. And then you do a mem copy. You do a mem copy to buffer plus 2 because we already defined buffer 0 and 1. And you're copying the payload. And you're writing the payload length onto it. Yes. And then don't do this part at the end. Okay. Don't add the null character at the end. And that should construct a frame. Oh dear. payload length. What is, what are we even sending? Right? We actually don't know what we're sending yet. What we're sending, I guess, roughly depends on what was requested. So I guess I could send I could send over a pointer. And what is this? This would be a char pointer, which is basically a byte pointer. And I mean, it's kind of an int pointer realistically, but whatever. We're gonna send them. What are we sending them? We want to send a pointer to client data. Client ID plus last index. Plus 1, I think. Maybe I do. It would make so. I'm trying to think. How is the client going to be keeping account of what they've received? And I think it would make more sense actually that the client starts out at 0, being like, I have received 0 messages, and then we just add 1 each time. So I think we do plus last index. I think that's how we treat it. It's either way, it's like an off by 1 thing. It doesn't really matter. But let's do it this way. Okay, and then so that's the new pointer that we're sending. And we need to know how many that is as well in bytes. Four times I mean, I'm doing all this like for stuff when technically I should be using size of int everywhere, but I mean, this code doesn't really have to be portable, probably, so I don't know. 4 times. Yeah, here's the weird question. Is so say the client has 5 ints stored, and so that's indexes 0, 1, 2, 3, 4, 5. No, 0, 1, 2, 3, 4. And a spectator sends me a request for that client, and they send me 1. So that means they want to receive 1, 2, 3, 4. So that's basically num elements minus last index. Times the size of the int. Yeah. Okay. So I'm pretty sure that's the data we want to send over them. Construct binary frame. That's no longer what we're doing. Message out. Wait. Okay, so we need to... I guess we have a buffer. We've got a buffer hanging out that we can just use for that. Yeah, it's fine, I think. It'll write it onto message out, and it'll send it. And we shouldn't send it to clients J. We should send it to clients I. Because I is the... I, way back here, is the current client. So, there we go. There we go. All right. I mean, it's anyone's guess if that's actually going to work, but I think it should. God, everything is so much harder to write and see. But it's so fast. It's so fast and efficient. If you do it right, that is. Cool. Yeah. What is this? Cool. Yeah. All right. Cool. Great. Awesome. Right. So I need to simulate this, I need 2 clients. I need 2 clients actually with different behavior. So I need to go mess with my client code to be able to handle that situation. Yeah. Okay. So how do I build in this functionality? It'd be kind of nice if I could just like type this out in the message thing. So let me mess with this send button. Send button.onClick. Here's what I will do. I will take you and I'll say dot split on comma. I was just going to do type annotation there for a second. Yeah, okay, yeah. And then send, we send that. So we send that. And so we need to just do this, basically. Let's actually do another line for that. Okay. Perfect. So now I will spin up two clients. Will both my clients be in separate tabs? I don't know. I'm not totally sure. But let's just see how that goes, right? Okay, we don't need the RFC right now. And we kind of like duplicate this. Okay, so like we keep this here. Alright, so of course the connection's failing. Okay, so we come over. I'm gonna go start my server. Okay, we didn't get any errors with starting the server, so that's impressive. That's a good sign. Okay, so we come over here and refresh you. And my server says, let me pop over here. My server says I have one client. Okay. And if I refresh this, my server should say I have two clients. Correct. Okay. So gonna do a weird sequence of operations. I'm pretty sure this guy, since he connected first, is client 0. So I'm gonna have him say 1 7 8 9 10 11 12. Enter. I sent the payload, allegedly. So if we look back at our server, did we in fact get that? 7, 8, 9, 10, 11, 12. Yeah. Okay. Does spectator work at all? Probably not. But what spectator will request right now is okay, first they have to say 2 client 0 and let's say 0. Just give me everything, right? I didn't build the code in to like decode what's sent to me, so I don't know what it's going to send back, if anything. Requested client 0 is out of bounds. That's not a good sign. Frick. First int is 2. Okay. First int is 2, so it got here, Yeah. It got here. Got client ID, it got last index. And it got here, basically. Requested client 0 is out of bounds. Which does actually make sense because this should be less than or equal to 0. I'm stupid. Silly me. Okay, so, but I should probably, like, print these things, right? Sure. Okay. Restart the server. We're doing it all again. Make sure that first client finishes connecting. Yep. One client. Two clients. I have two clients. Okay. Client 1 sends 1, 7, 8, 9, 10, 11, 12. It received it. Client 2, the spectator sends 2, 0, 0. In theory, I sent it. Okay. All right. I mean, that's kind of a bummer because the I don't think this knows what to do with the message that it received. I don't think it does anything with the message it receives. Okay, so let's pop over to that. Save. Okay, back to the client. What should the client do when it receives a message? It receives add event listener message receive. Receive is my function. Aha. What does it do with... What does it do with binary data? It's acting like it didn't receive anything. It actually should have... Message event. Message event. See, now I don't know the details of message events. Data is an any. Event.type. Event.source. Event. Huh. Yeah, it really should have displayed it or something. Should have done something with that data. Yeah, I don't... I'm gonna console.log it to see if that does anything different. That's strange. It's very strange. Okay, so we pop over to the game server real quick. Okay. Run the server again. And we pop open the clients. OBS is being dumb. All right. I have 1 client. I have 2 clients. Yep. Seven, 2, 3, 5, 9. Yep, that's what was received. I'm going to send 2, 0, 0. Absolutely nothing in return. Why? And there's some other client that's like being stupid. Just some random noisy activity on the internet. Who cares? Okay, it's just like literally not sending anything. Why? Why though? Neither of my clients say that they got anything. Oh? Oh dear. Huh. Does that mean that like it was expecting to receive more data or something like that, and it's just because I like didn't structure the frame correctly? That could be it. That seems not unlikely. Well, I'm gonna have to figure out another time because I've been streaming too long. I'm tired. I'm tired. It's late. Oh yeah, it's late. Um, I would have loved to have a success right at the end, but I didn't get it. That's fine. I will figure this out the next time I stream, or maybe not on stream. No promises. I'm such a great streamer, aren't I? Gosh, a consummate professional. Keeping his schedule and everything. Um, yeah, but this was cool. Mostly I was just like trying to decide how I wanted the system to work. But I definitely feel like we made some decent progress. Um, Thank you so much for watching. And I hope to see you again soon. Maybe tomorrow, maybe like a month from now. Who knows? But until then,